Hey everyone, I hope you're having a great time. So in the previous section, we saw the introduction to VPC and we saw what it was all about and I said the expectation. In this video, we are going to learn about networking 101, which is something that I wanted to introduce for people who have no idea about networking, but when they are looking at this section, they have a lot of clarity into what's happening. So for people who have already gone through courses like CCNA and so on, please do forgive me if I say something wrong, and you can always correct it and give me comments on this course so that I can go ahead and correct that lecture. Okay, so let's get started. With networking 101, we have the first topic, which is IP address. So in one single sentence, an IP address is something that is used to uniquely identify a resource within a network. And then the next one is called as OSI model or open system interconnection model. This is something we have studied in our third year of college when we studied the networking labs. And with that, you have 7 layers of OSI. The physical layer where you have all of your devices like routers and switches. You have your data link layer where everything is converted into zeros and ones. And then you have your network layer where you have protocols such as IP, BGP, and so on. And then you have your transport layer where you have protocols such as TCP, UDP, ICMP, IGMP, and so on. And then you have session, presentation, and application layer. And in application layer, you have protocols such as HTTP, HTTPS, and so on. So this is how your packets travel through the network through all these 7 layers. So it's very important for you to understand the OSI layer in terms of all the 7 layers in terms of understanding how a traditional network works and how your packets are traversed through all of these layers. And I would like you guys to do a small homework in regards to researching more on the OSI model. And then the next concept is in regards to private IP versus public IP. So with a private IP, I'll be able to talk to all the resources within my network, whereas with a public IP, I can talk to resources in the internet. So a classic example for you guys is that when I go to my MacBook and I type ifconfig, where ipconfig is in Windows and ifconfig is in Mac, you can see that I have a network interface called as EN0, which has an IP address of 192.168.178.189. And this is my private IP. Whereas when I go to Google and I type my IP and I go ahead and open up the first address, I'm using the host over here, which is my public IP. So you can see that it's 83.162.151.120. And you can see this is the ISP provider. This is my host IP and my remote port. And you can see that this is my public IP address. So I would use my public IP address to go ahead and talk to resources in the internet, whereas I will use my private IP addresses if I want to go ahead and talk to resources within my network. So probably if I talk from my MacBook to another one of my MacBooks, I would probably use my private IP if they are on the same network. And then I would use my public IP to talk to resources within the internet in terms of downloading any packages or opening any websites and so on. And then there is this one range of private IP addresses called as RFC 1918 standard, which has these respective IP addresses. We have the 10.series/8, 172.16.series/12, 192.168 series/16. You can take a look at this on Wikipedia as to what that standard is all about. But then any network that you take a look at in any household or wherever it may be, you will see that all those networks have the private IP range from one of these 3 ranges, which is 10./8, 172.16/12, and 192.168/16. Okay. And then when it comes to traditional networking terms, you have 2 IP addresses that are reserved, which is the first IP called as the network IP and the last IP called as the broadcast IP. So if you take any big network, you will see that the first IP is reserved and the last IP is reserved, which means all the IP addresses other than the first IP and the last IP can be allocated to all of your hosts. Right? And how do you get these IP addresses? That is something that is assigned by something called as the DHCP server. And then your IP addresses are assigned to your respective network interface. So the network interface gets a private IP and a public IP as well as a MAC address and so on. So this is in terms of traditional networking terms. I would like to just do a small bit of revision is that an IP address is something that you use to uniquely identify a resource within a network. And how do your packets go around a network is through the OSI layer and all these 7 layers. A private IP is something that I use to talk to resources within my network. A public IP is something that I use to talk to resources in the internet. And there is a standard of private IP ranges, 10.series/8, 172.16 series /12, and 192.168 series /16 that is allocated to all the households. And then in traditional networking terms, we have some reserved IPs, which is the first IP and the last IP of every network or subnetwork is reserved, but every other IP address can be allocated to the host or the resources within that network. And what allocates it is called as the DHCP server. And at the same time, you are getting all of these IP addresses allocated and attached to a network interface. So when you take a system, that system has a network interface to which these IP addresses are allocated, and also a MAC address is allocated to identify each and every device on the hardware level, which is unique. So the MAC address is on the hardware level by the manufacturer, whereas the IP address is allocated to the network interface, and you have a private and a public IP. So I hope you got a basic idea in regards to how networking works. We will take a lot more detailed approach into how subnetting works and all the other terms that I have mentioned over here in the next video. So thanks a lot for watching this video. I hope you had a good time. I'll catch you on the next one.